we have 2 more weeks. So this week, on Wednesday, no class, so you can enjoy Thanksgiving holiday. If you get around with your family, you can enjoy. Otherwise, you can do homework project, preparing your final exam, and so on. So our final exam is scheduled December 11, Wednesday. It's not my decision. It's by the registrar office. It's at 10:45 a.m., 12:45 p.m. I don't think we need 2 hours, but anyway, 2 hours is assigned. Then in this classroom, the coverage is after midterm till any subject that we are going to cover. Okay, so basically it's the same format as the midterm exam. I'm going to ask the final exam usually 20 multiple choices, and the other will be open-ended question. So I will give them more information after the Thanksgiving. Okay, and today we are going to cover the transaction management. So after the Thanksgiving, we are going to have the final project demo. So you can be ready for the demonstration of your the project. So it's December 1st. Each team may have around 10 minutes. And I'll show what you implemented. You don't have. It is okay to prepare the formal presentation part, but the more important thing is you need to demonstrate the system. It's a live demonstration, okay? Because we are using the cloud service, so it should be available at the time. Okay, and no class on the Wednesday. Any questions? Okay. So. Did you take the operating system class? So operating system class basically consists of 3 parts. One is the process management. So you probably learn how to create the process and how to manage the process. So process is the most important data structure in computer system that through the process. So we can use the computer resource such as CPU, and the memory, the storage, and so on. Then in addition to the process, we probably you learned about the memory management, because memory is the storage, primary storage, which will be used by the processor. The processor is mostly computation part, and to get the data. Even though processor, the CPU has the storage like the register, so it's very small, so we cannot fully, we cannot rely on only the register. So we need the primary storage. But even the primary storage memory is not big enough, so definitely we need the secondary storage. Mostly it's a persistent the storage like the file system. So when you talk about the process, the first part of the process management is how to create a process. Also, you probably learned about how to use a drive like that. Then, second part of the process management is, let's say that we have the 2 CPU, CPU1 and the CPU2. Nowadays, we have a multiple processor on computing architecture or the multi-core system. So the difference between the core and the CPU, multi-core and the multi-CPU is a multi-core system. Both of them process separately the thread of the instruction, right? So we can get the benefit of parallel processing. However, if you separate the chip, like the CPU1 and CPU2 is a multi-processor system. On the other hand, the multi-core system is in the same chip, chip. So inside the chip 1 CPU, you have multi-core, even though each of them processes separately. So we can save the energy, we can save we can reduce the complexity of the cache area like that. So this one is nowadays very more popular. It's more complicated, this one. But to simplify the problem, let's say we have the multi-processor, which means that each CPU process the thread of instruction. So for example, if we are using the thread, the programming, you can create the multiple thread, then we can get the benefit of parallel processing. But sometimes you need to access the same data on the primary storage. Mostly it's a RAM in the memory. Okay? Let's say the CPU1 is doing increment the value +1. Okay? On the other hand, the CPU2 is decrement the value. This is the CPU2. Okay? Even the instruction level, we have such the instruction. So like the increment and the decrement, the by 1 and by increment by 1 and increment by 1, like that. Then we have the data A. A currently is equal to 0. Okay? And when we run the same program, it's like A. It's like this A. Like this. Okay? So that when we run this the program using the multiple CPU, then what will be the output of A? So it can be. So what is the basic operation? So first CPU need to copy A, read the data to the register. Okay? Using what? For example, move instruction. So always you need to copy the data. You cannot directly modify the data on the memory. Instead, you need to read the data on the storage, it's a register. So using the move. So move can move the data from memory to memory, memory to register, register to register, register to memory, like that. Okay? So as you learn in your microprocessor class, right? I think the microprocessor class covers the assembly. So there. So you have A is equal to 0. Maybe the CPU to read to operate this operation, the read the data is a 0. And this one going to be 1, this one going to be -1. Then the CPU1 write the data and the CPU2 write the data. It's override. So it will be -1. Or vice versa, it can be 1. Or it can be +1, then read the data, -1, it can be 0. So we cannot guarantee the output. Right? So this problem is called schedule. It's called this issue is called race condition. They are compete the shared data. It's a race condition. In case of race condition, what happens? We cannot guarantee the output, which means it's not synchronized. So it's a synchronization issue. The process synchronization is one of the important part of the process management. So how do we address this problem in operating system? Do you remember? You learn. So basically, it's a locking. So you lock the data, then the process and unlock the data. The problem of such a basic locking, the solution is when you lock the data, you cannot the process or the other users cannot take this one, should wait. So you learned about the operating system solution, hardware solution, or something like that. Okay. Then at the time there are a bunch of different solutions. So, but it's starting from the Pearson solution. Pearson solution can address the the process case, but we have multiple processes. So there are the requirement of the synchronization problem. So I cannot remember everything, so you can find. So there are a lot of them, but that will be happen. So basic solution is you can lock the data, then create the critical solution. If the shared data is modified, you can declare this is a critical section. So you can select the resource that would like to access. So think about you are going to use the bathroom. So it has only one toilet, but people are waiting outside. So you can the first one first, sir, or sometimes somebody really in a hurry, so you can vote. So this critical solution is critical section problem. Solution is those who are waiting for the critical section, you can vote. Okay? Then eventually access the data and release. And it's the rest of the section. Then there are requirements, so it will not, any process cannot wait infinitely. Eventually take the resource like that. So this is a synchronization problem and your solution that you learn. What about the database? Database also have the same problem. Especially database use the database, the file system, database system, and there's on the hard disk drive and or the persistent storage, and we have the many users. Definitely it has such a synchronization problem. So I think that at the end of the operating system synchronization, the chapter, at the end of the chapter you probably learned about one of the solution is, anyone who remember? It's using semaphore. Semaphore is one of the solution. You can use the semaphore. Or the spin lock is one of the issues. Keep requesting whether it's available or not available until available. Keep asking. So it looks like as if you are knocking the bathroom. So come out. So like that. That's the issue. That's one of the issue of the solution, and that's a spin lock. But in the one of the solution you probably didn't pay attention to a lot is using transaction solution. So why don't you look up your operating system textbook? It has the transaction. So transaction is used a lot, right? So my transaction is failed, or the transaction is slow, so transaction is blah blah. What is the transaction? Especially in computer science. Exchanging data. Or in general. So like the banking transaction is slow or fail. So for example, I try to transfer, so the transaction for the transfer is failed because of the network is slow, something like that. Then think about the transaction for transferring your money from your account to your parent. So how many operations inside? Is it just one operation? There are multiple operations inside. So even though we create one transaction, first read the data from my account, then check whether I have enough balance. I try to transfer 1,000, but first check whether over 1,001. Then if yes, then the withdraw, take out the 1,000. Then send such a data to the receiver, your parent account. Then check where parent account is valid. If valid, but what happened? Your transaction is failed. Then you lose the money, but it's not the deposit. Okay? Then you need to recover, right? So even the one transaction has a read, write, multiple operations. So transaction is the group of operation. It's the set of operation, but this one is the logical unit, which means it's the atomic the unit of the group of operation, which means if this transaction is a fail in the middle, it should be recovered, restored. So all or nothing. Okay, to avoid such a synchronization problem. So we can use such a transaction concept. Actually, not only application like the banking application or database application, but also operating system use such a transaction. It's a logical unit. It's not physical unit. Physical unit is a read or the increment and the write. This is the physical unit. Physical unit means it's the system library or instruction. One of the characteristics of the instruction is It's an atomic. You cannot stop in the middle of instruction, right? Once start, it should be done or not. So it's an atomic operation. But this one, transaction has, but the most of our operation, the program need multiple operation of this one. The problem is we cannot keep such a synchronization. To keep the synchronization, we are going to logically. Logical means not this hardware level, not instruction level, my programming level. So define this is the all or nothing, atomic unit of the operation. Okay, which means the transaction has multiple read and write and such a operation inside. Then it's the all or nothing. In case of the fail something wrong in the middle, we need to restore any change of the data. Then we can keep such a synchronization issue. So also we can lock the item shared data based on the transaction. When the data is processed by the transaction, then we can lock the data, or sometimes you can share the data. We will see that today. Then, from the database, the perspective, what kind of operation we have in our database. So, like in this, the example, we have the read, increment, or something like that, such as the system library. But in database, we can say there are two basic operations in a database system. Insert means right, and read. Any other operation? Actually, read and write. So database actually basically consists of a bunch of read and write operation. So especially when you read the data, it's not a problem. The problem is when you write the data. So we are going to focus on such a write. So, but it's basically the synchronization problem. So how to address this synchronization issue in database? So using transaction. So today we are going to see how to manage such a transaction. So transaction management is needed when we have multiple users. Okay, multiple users. If we have the single user, so I'm the only user, we don't have to worry about that. So long time ago, the Microsoft, the SQL Server, the Microsoft started from the 3.1 and 95, the 97, 98, or the Millennium Edition, so on. But long time still, any other your friend or family member who access your laptop? No. Probably not. Most of the Windows-based system is a single user purpose. Even until the Windows 98, until the Windows NT, they don't allow to access your data. So only you are eligible to access your operating system, Microsoft Word. So it's still the personal purpose, individual system. So database, SQL Server also allow only one single user. But after the network is connected and nowadays using the remote desktop, so you are able to access your operating system, Windows, operating system. So definitely the Microsoft SQL Server should allow the multi-user system. To do that, this transaction management should be included. But they didn't have such the transaction management module, so they actually purchased such a module from the Sybase. I'm not sure whether you guys have heard about the Sybase, the relational database. People say that in the academia and research, Sybase is one of the best, the relational database in terms of architecture. So in terms of architecture, Sybase is fully follow the idea of the relational database model that we have learned. So some of for example, Oracle database. Oracle database started from the Oracle the version 2 and so on, and from version 6 they released the commercial product. Then from the Oracle 7, it's really popular, everybody use. But after that, Oracle usually add more and more functionality. So when they start the Oracle relational database, it was good. So in terms of architecture, but they plug in a lot of the edit, like the object oriented. It doesn't make sense. The relational database use object oriented concept, as you learn from the relational database model. Relational database model does not allow nested table inside table. No. Also, object oriented concept. So how can you identify the object? OID. The object ID. Object ID is a reference ID. It's actually in a memory. So you are going to create the object using class. Okay, then you are able to access such an object. Then you can also create another sub-object, sub-class, like using the inheritance. At that time, you don't have to create everything. Instead, you can inherit the superclass for the subclass. So we can simplify the program. What about the relational database? No such a thing. Okay, we just consider relation table, not object table, or the relation as a group of data. That's it. Okay, so it doesn't make sense to adapt the architecture of the object-oriented concept to the relational database. But people want, so they pretend. So add a bunch of different things. Even nowadays, the big data component or the NoSQL component. So it's really big. The database, the corner. So because of that reason, when you install the Oracle by yourself, you need at least 8 GB the memory, and when you start the Oracle database, your system is very, very slow because it's too much. But when the Microsoft projects the transaction model of the Sybase is one of the best. But as you know, the quality is different from the success in the market. Okay, so they couldn't survive. So nowadays it's very hard to see the Sybase. But anyway, so Microsoft projects this one. Then right now it can support the multi-user system and the multi-transaction. So today we are going to see what is the transaction, then how we can use such a transaction in our basically application, database application. Okay, you already use such a transaction part, but whether sometimes you may not realize such a transaction. So today we are going to see such a transaction. So if we have the single user system, we don't have to worry about too much such a thing. But when we have the multi-user system, when we are talking about such a user doesn't have to be the human being. It's an application. Also, it can be another system. It can be operating system. It can be computer. So it's a multi-user system. At that time, we need to think about the concurrency. So there are two characteristics of such a database. One is a concurrency control. Another one is a consistency. Easily is confused. So what is the difference between the concurrency control and the consistency? Concurrent means same time multiple users can use the data. So if you do not allow concurrency, which means at one time only one user can access. For example, like somewhere we have. I think it's different. For example, when you have the one CPU, a user one access the data. But if there is other request from the user two, so you cannot run together. Instead, you need to wait until the end of user one. It's a kind of, if you have multiple, like that. So it's an interweave the fashion, so you can use the resource. So it's not concurrent. It's only a single user system. But multi-user system, if you allow the multiple user, so you should support the concurrency. On the other hand, consistency means, what is a consistent? In general, consistent. Dependable. You can expect, okay? You can expect something. It's not like the randomly changing. So in database, we define database state. Do you remember database state? Database state means schema plus data. At certain time, there is database state. Okay, that is the kind of a status. Then, if you change the database, like the insert, you insert the data. So your database will be changed from one database state another database state. And also that the next database state should be expected. Okay? If you insert the one, but your database doesn't reflect your request, it's like you insert the one, but there's no one. You update 1 to 2, but database has 3. When you access the data, it's not consistent. Okay? So, but relational database is really, really strong, consistent. Is there any database which is not consistent? What do you think? Yes or no? Are there any inconsistent database? Yes, you are using every day. Think about the Facebook. So when you upload a Facebook message, so is it real time applied to the database? So think about you send a message, post a message to your friend Facebook in India, but your friend cannot see your message right away. Okay, even though you insert the data, even though you upload the message, you probably realize even my message sometimes I refresh and apply the later. Why? Because the Facebook use distributed database. If they have centralized database, it's a bottleneck and network latency, so they have the regional distributed database. So when I upload my message to the North America, it will not be synchronized in real time. It's still overhead and takes a time. So it takes a time to apply to all the other, which means it's inconsistent. It's not consistent. Not always it's consistent. So, but the relational database is very, very strong, consistent. So we will see after Thanksgiving how the relational database keeps such a consistency. Then such an inconsistent, sometimes it's eventually consistent, or such a thing is the NoSQL database. Because NoSQL database is not like the relational database. So if your banking system is inconsistent, you are going to sue your bank, right? If stock market trading system is not consistent, definitely you will sue. Because I tried to buy the stock, Microsoft, but it's not consistent. So my friend, the buy, even though transaction is late, but the other can buy. So it will be problem. However, Facebook start. Are you going to sue if your message is not posted in real time? You may complain, but you will not sue. It's not a big issue. Okay? So that is the kind of idea of a NoSQL database. So nowadays, more and more NoSQL database is used, like the MongoDB, Cassandra, and so on. So in the NoSQL database course, we will discuss about it. But here, relational database, keep in mind, really, really strong. Really, because of that, relational database is limited. Okay, the hazards consistent. But here, transaction management try to solve the problem of the concurrency control, multiple users. So at the time, if you have the resource, like the one single CPU, so interleave the processing, like the hectare, as you learn in your CPU scheduling. CPU scheduling is kind of the interleave the processing to maximize the utilization. But definitely, the database supports such a multiple processing, the multi-user system. Okay, so what is the transaction? Our solution is the transaction to solve the problem of the synchronization. So it's the logical unit of database processing. That includes the operation. But in a database, as we have said, is a read or write. Any other operation? No. So we can simplify the problem on the read and write. Okay? In case of write, it's just insert, update, or delete. So read is query the data. So transaction, database transaction, always start with begin transaction. So begin transaction. Any database transaction should start with a begin transaction. Did you type any begin transaction when you are using MySQL or in your database programming? Did you use such a begin transaction? But it should. Actually, SQL 2 standard, from the SQL 2 standard, whenever you connect the database, automatically start the begin transaction. It's an automatic start. So because of that, you may not realize existing of a begin transaction, but explicitly you can declare the begin transaction. Sometimes you need to do in a database. It's something critical, the application. So you need to declare, I'm going to start this time, the begin transaction. Then end with end transaction. Have you ever used end transaction? Probably not. It's automatic, not automatic, but there are other, it's a commit. The commit, what is a commit? When you update or write, when you insert, update, delete, which means write operation, you need to commit. Commit means permanently apply. Okay? So that is a commit. Sometimes you can end the transaction with abort. Abort means go back to this database state. Okay? I'm going to cancel. But that's also end of a transaction. So you can end your transaction like the commit or abort. But it is important to explicitly type the commit. Sometimes you didn't type the commit, which means when you exit MySQL, depending on your option, okay, configuration, it can be automatically commit or there is automatically the go back abort. So you need to check. Some of the database application is auto commit, sometimes auto the rollback actually. So you go back to the beginning. But in your program, if you successfully finish the database program, so it means it's automatically commit. Okay? So your transaction database life cycle is a begin transaction to the end transaction. If this transaction is really wrong, okay, during the something, as I said, is all or nothing, which means if something right, but if your transaction is failed, you need to go back to the beginning. How do you know this database state? We are going to see later, but we are going to use the log data. Okay, log means, so 1 is 2, 2 is 3, 3 is 4. You change. So you keep all this information before and after. In case of abort or something wrong, go back to the original data. So which means we are going to keep the log data for the transaction. What if this one is really long transaction, like to update 100 petabyte size data? Your system need a huge size of memory as well as the log data. So from time to time you can checkpoint. So checkpoint is a partial commit. So partial commit, partial checkpoint A, checkpoint B, checkpoint C. You can go back to the specific checkpoint. Go back. That is called the rollback. There's another one, rollback. Rollback means it's a go previous database state, not apply. So checkpoint, you can go back to the specific checkpoint or go back to the beginning in case of a rollback. So this is a transaction. But just like many other systems, it's abstract. So you may not realize such the operation of a transaction Instead, it's mostly the auto commit, so auto beginning transaction, auto ending. But the mission critical system, you should declare clearly, because the starting of the transaction is very important in the stock market, because who is the most popular group? Like some of the very popular group, when they have concert ticket, when they sell the concert ticket within a minute, so millions of tickets will be sold, right? So, but still at that time you need to manage them. There are other way. Actually, they do not use this one. They use the queue. Okay, as a request. It's the group. There's a queue. There's the first come first in. Then they process each of them. But some mission critical system, you need to check the beginning of the transaction. So to keep the beginning of the transaction explicitly declared. Okay. So this is a transaction. So here is a life cycle of the transaction. So starting with the begin transaction and end with the either commit or over. You can terminate. Okay. In the middle, you can partially commit. Partial commit is a checkpoint. You can go back to the specific point. So this is the life cycle of the transaction. At this time, the transaction has basically has the two parts, read and write. So read and write of what? Read and write of what? Data. So we can consider the database, the structure. Like we learned about database. Database has a schema. Under the schema, it has the table. So under the table, it has number of attributes and each value. So that is called the database, the granularity. So database granularity means it includes the field level value. And the record is one instance. And the whole disk block is a physical level. And also you can consider the entire database. So when you write something can be one of these. Okay? It's not just the value itself, it can be entire record, it can be entire database. So read, write. So from now on, I'm going to say the X. X means it can be data, it can be record, it can be table, it can be any level of granularity in a database. Okay? Then, so we can say the basic operation as like the read item of X, writing item of X. Okay? What happens when you read the data? So when you read the data, this is our computer system. This is the memory. As I said, the database management system requires cache area, so buffer management. So let's say this is a database buffer, okay, used for the database cache and storage, physical storage. So let's say we have the table, student table, name is A, okay, name is A. So if you read the data, select the name from student, then any condition, so then it will be processed, query processor, query optimizer, and the database, the query processor will read the data based on the execution plan that we discussed last time. Then first, it doesn't return the data directly to the user. Instead, search the memory, the buffer, whether there exists the name. Okay? If yes, we can return the data from memory. Otherwise, copy this data to the buffer. Okay? This buffer is a block by block. Database block. Do you remember the database block? It's a basic unit of I/O. For database, it's a multiplication of multiple of what? Operating system block. So like the multiply by 512 byte, sometimes 1K, 2K, 1 megabyte, several megabyte, And also, big data use 128 megabyte, 256 megabyte block size, which means entire 256 megabyte will be copied to the memory in a big data system. So this is the buffer. Let's say this is the 512 one. Then copy. Then return this one. And next time, if other user read the same data, this one will be returned. That's the read operation. In case of writing operation, it's basically same thing, but you need to copy this data from the memory. If it doesn't exist, copy A, then copy another one, then update A to B. So we do not update directly this. Instead, A, then B. So this will be returned to the user. Why? Why? Why do I copy instead of directly update the data? Yes?
Because you'll misplace the address in some form. You won't know where to reference it from.
But this is
in case of rollback.
that's one thing, but that can be stored at also the permanent storage. Think about we have a huge size of the update. You cannot keep all of this. What if? At the same time, before commit, transaction is not end. It's in the middle of transaction, so it's not permanently applied. And the other transaction, this one, select the data, not B, should be A, right? We need to keep the before image. Okay? So this one is the before image and after image. So we need such a copy of the block when we update the data, when you write the data. Then this one is called the before image. This one is after image. So this after image is sometimes called dirty image, dirty block. Okay? The dirty block will be used. Then, if this one is a commit, okay, what happened? It's a permanently applied. Do I write this data to the here and B? Commit? Yes or no? When you commit, what happened? Yes, we do not write the data even though commit. So still A, and this one is a B, and this one even A. We keep all of this. Then later we will update this data to the hard disk drive like a B. Why? I mentioned a couple of times before. Think about your USB. What do you need to do when you unplug your USB disk? Save. Why do you every time save and remove?
Because it could still be writing or reading from it.
Right? On the memory. Okay. Always operating system update the data from the memory, not hard disk drive. Why? So slow. Hard disk drive is much slower than the memory. When you write the data, yes.
Is the memory RAM or is it cache?
RAM cache is the same thing. Okay? Random access memory is a primary storage. When I say in the memory buffer, it's the primary storage. This one is the secondary storage, like the SSD or the hard disk drive is a secondary storage.
So because the capacity of the RAM will be less.
And also it's less, but it's fast. So when we write the data, even operating system, they update on a memory. And from time to time, we apply such a change to the hard disk drive. This one is called the deferred writing. Deferred writing. So deferred writing is used not only database, most of database, the computer system application, including operating system. Because writing the persistent, the hard disk drive file system is much slower than this. Okay, so it's still B. Then why do we keep the A, even though commit? Roll back? It's a commit. There's no reason to roll back. After commit, no rollback. What if it's a multi-user system? This one is read the data. Okay? So it should be A, right? But it's a, even though commit is still running, it should be A or B?
It should say when we start.
Start. That means A. A should be aware. Okay? So that is the reason we are using transaction management to keep the consistency of the data, or for concurrency control. So based on that idea, so when we read and write, we already discussed about that. The mechanism is important to understand the later consistency management also. So when you write the data, so it should copy the previous one, original one, and then you update the after image, the dirt server. Okay. Then, what if we do not have such a concurrency control? What happens? We already talked about that. There are several problems if we do not have such a concurrency control with the transaction management. So for example, lost update are the problem. Okay? So we already talked about that. So when we do not have the transaction management, so first, lost update the problem is, so I think that we better use this one. So there are two transactions, okay? It's the same as a synchronization problem. So this one minus, this one plus, okay? But if this one update the data later, so we lose what? The transaction one update, right? So it's the same problem as the synchronization. So that is called the lost update problem. The second problem is a dirty read problem, temporary update problem. That means if we do not have such a transaction management, this data changes to the A to B, okay? Then when this transaction read the data, it will be B. But what if rollback? It read the data B, but it's a rollback. It's going to be A, but it's just read the temporary update the data. So because we do not have such a transaction management module. Then the incorrect summary problem is mostly happen in even where the DBMS system. For example, TX1 and TX2. So this one, transaction one is the calculating average salary. So it starts 10 a.m. and end with 2 p.m. Takes a long time. So transaction one. Transaction two is from the HR department. They update the data, salary sum of employees. Okay. So if you update the data, what about the result of average salary? Is it before or after? If we do not have such a transaction management, we cannot guarantee. Okay, that is called the incorrect summary problem. This one really happen in even the real DBMS system. For example, Oracle has error code like this one. Why don't you search the Google? What is this? ORA-1555. So why don't you search the Google right now? What is the name of this error? Snapshot to all. Meaning is, whenever you update the data, you need to before and after, right? And when you read such a long transaction, read the data before image. This one should be before image. Start at 10 a.m. This one start at 11 a.m. Right? But if the update data memory is limited, so you may lose some before image. Then this transaction cannot find the before image. Physically happen. So snapshot to old is one of the real example. Such an incorrect summary problem. How to solve the problem? Solution probably run it again. After this one is done, run it again. So all this problem comes from the transaction management. So also when we talk about the transaction, so previous one, we need to roll back. Roll back means going back to the original data, starting point, starting database state, which means in case of failure, we need to restore data. So when we talk about the failure does not always means like the disaster, like the computer system is collapsed, but also failure happen, network failure. Well, if the network is slow, sometimes your transaction is, like the banking transaction is, it's a stop, it's a failure. And also if the application is not working, it's a failure. At that time, if that happened in the middle of transaction, we need to recover. Recover means going back to the original database state. Okay? So then such a recovery, going back to the original state, will be used for the backup and recovery. I'm going to introduce very briefly about the backup and recovery later, but if you understand the transaction management, so backup and recovery is the branch of transaction management. So you can recover, restore the transaction. Okay? So backup and recovery will be done if you have the transaction management. So transaction, we already talked about the transaction. This is a transaction. Always start with a begin transaction and end transaction, but nowadays, so they are abstract level. So which means you may not realize the beginning and end of transaction, but there are. There's such an in between, and read and write the data. Okay? Then the commit. Rollback means is in case of the failure, in case of something happen, you want to go back to original. So that is kind of a restore to the beginning of the transaction. Okay? At that time, there are two operations. When you restore, when you roll back, so I erase that part. So it's a begin transaction and end transaction. So in case of something happen, we need to roll back. Roll back is the restore. Then how to restore the data? How to restore data? At that time, we need to consider two operations, redo and undo. So undo means it's let's say that we have update the A to B. So originally A. So we copy A here, okay? Then B. Okay? Then it's for example, this one is commit. Let's say we do it first. But this one is easier to understand. Commit. Then commit means this one is permanently applied. It doesn't mean that this one is A. Okay? So it's still A. This one will be used for in case of any select the data. However, at this time, so somebody unplugged the power. Okay? Somebody unplugged the power. What happened? You lose this. Why? It's a memory. Memory is a volatile. But you may not lose. You do not lose the data on your persistent secondary storage. It's a hard disk drive file system. It's A. So when you reconnect the power, what happened? Is it A or B? This is still A, which means it's inconsistent. So we need to address that problem. So how to address that problem? We need to redo the operation. This operation should be redo. Okay? So this one is called the failure because your system is unexpectedly down, right? It's a failure. We need to recover. It's called the instance recovery. How to recover this one? We need to have this operation update. So there's a time. Then you can check this time. Last updated time. Let's say last updated time is the November 10, so 10 a.m. But this operation is in the November 10, 11 a.m. This one is the latest one, which means should apply. Redo the operation and commit. At that time, how can you find this information? Log. So whenever we operate the database, so we need to log. Sometimes it's called the journaling or log data. So it's called the redo log. For redo, we log the data. So this is another important thing when you manage the transaction. It's called the write ahead the log, or sometimes WAL system. Write ahead the log means whenever you commit the transaction, just before commit, just last step of the commit, you need to write the operation. This operation to this one. This one is called the redo operation. Okay? So this one will be used for what? Backup and recovery. If you back up the log data, you can restore your system. Not only just one transaction, many transactions. This one is not only for the database, but also your computer system. So if I unplug the power, forcefully down, then unexpectedly shut down, not gracefully. Then when you plug in your computer system, usually you may realize it takes a longer time, right? If your system, like the Raspberry Pi, any operating system, any computer system, if you unplug the power or the forcefully shut down, when you start again, it takes a longer time. Why? Because of instance recovery. So it's exactly the same mechanism. So that's the reason all of the system log any operation. Operating system has to log, network has to log. They are doing the same redo operation. Then you understand. So what is a redo? It should be applied, but it's not applied yet. You need to redo the operation using what? Log. Then undo is probably opposite, right? Undo should be go back. So for example, one of the examples is this one. I update salary. Salary times 1.1, 10% increase. How many employees? We have millions of employees. It takes a really, really long time. Okay? So update, whenever I update, before image, after image, before image, after image, right? So where? Memory. But memory is 1 gigabyte. But this before and after need 2 gigabytes of the memory. We cannot update the data. So from time to time, such a after image, new data will be applied to the hard disk drive, permanent storage, even though it's not coming. It's not coming. It's not coming, it's applied. So to have the more space or no memory. The problem is, what if somebody roll back? We need to go back to A, right? Where's the A? We do not have A. So we need to have another storage that is called the rollback segment. This is a hard disk drive. Rollback segment that keeps the all before and after image. with the memory. In case of the memory, it doesn't exist on the memory, the rollback segment will be used. So later, when we go back to the original data, rollback or start up your system, it's supposed to be A, but it's a B. We need to go back to that. How? Using rollback segment. Rollback data, we can undo operation. Go back to the operation. So this is called the undo. Actually, the database
Is that rollback segment a permanent?
permanent. It should be permanent storage. So whenever you update the data, this data will be stored at this one. Okay.
And what's the basic difference between that log and?
The log is to keep all your operation history. Okay. On the other hand, the rollback segment has only data, before data, after data. When you commit, we flush out. We don't need. Okay. After commit, this one will be used, right? For redo. But before, until the commit, we keep the before and after on memory, and also the hard disk drive. Okay. So that is for the redo. So undo. First redo. Redo is a transaction must be redo. It's supposed to be the new data. If not, we can redo the operation using log data. Undo is supposed to be previous data, okay? But it's not committed data. So we need to undo, go back using redo and rollback information. Okay? So there are two, actually basically any database system recovery is a combination of undo and redo. Then, where do we keep such a log data? On the log or journal that has basically time. Time is important because it should be synchronized. It should be determined when which one should be applied, which one is not. Time is very, very important. Then the operation, the commit or avert such an operation will be stored. And that is a reason system log should be backup every time. Not only data file, but also log data should be backup. A lot of, not nowadays, no, but if you manage your own database, a lot of the administrator forgot to back up the log data. You should. Okay? And this is the process of the recovery. So combination of the undo and redo. Then that is the transaction. So we are going to define what is a real transaction finally. So our transaction has the 4 characteristics. Okay, this is very important to understand the relational database. So comparing to the NoSQL database, other DBMS system. So it's called the ACID. A represents atomicity. Atomicity means so all or nothing, as we have seen, begin and end. This is the atomic, like the what? Instruction level, all or nothing, not in a middle. So that is the atomicity. It's very strong. Because of that, we can guarantee the transaction on relational database. When you transfer your money, so yes or no, not partial. If you banking transaction allow the partial, they withdraw the money, but it's not deposited to the other. Consistency preservation means one database state, next database state. So we should that system should be expected. So which means if transaction is complete, so that consistency is preserved. In other words, one database state, another database state. But other counter example is Facebook, like the distributed system. They do not preserve the consistency because they focus on what? Distribute. That's more important because if when you update the message, so it's locked, everybody should wait. So nobody wants such a thing. Even though you cannot see the one message, but you should allow to access the data. So that is a consistency preservation. So then isolation means when you have the transaction. So this is my transaction A. So I update, the delete, and select the data and the changes. It's not visible, accessible by other transactions. So this is the isolation. So until when? Commit. So for example, A changes to B. Even though it's a B inside this transaction, you can use the new data. But the outside is a B. However, this isolation is not just a fixed one, different level of isolation. For example, so most flexible isolation level is you allow, even though before commit, you allow to access the new image. Okay? You can allow. The most strict, the isolation level is even you do not allow access to this, lock. So A will not be accessed to nobody. Okay, nobody can access the A until this transaction is done. It's the highest level of isolation. So database management system provide different level of isolation. Okay, so you need to consider database is not most strict. So basic rule is it's just a rule of thumb. If the database system, the database user would like to access the data, system should allow. So which means not highest level of isolation because it's locked. So nobody want to wait to access. So you should be able to access the data. Also, if you want to update the data, write the data, you should allow nowadays. That means A change B. Transaction B would like to change A to C. Is it allowed? Yes. How?
Because it still only has access to the original.
So it can be accessed within this one and all entire system database schedule the transaction operation level the schedule. So that is called the transaction scheduling. Okay. So database allow any operation for the update and the insert, delete, and read the data. So they allow, but different isolation level. And durability or permanency means once commit, it should be applied permanently. Using what? Right? A head row, like a row, the undo, redo operation, like that. Okay. So ACID is the main characteristic of the relational database transaction. This is a really, really strong characteristic. Because of this one, the database, relational database capacity is limited to keep the consistency, to keep the isolation, to keep the durability like this one. It's more complicated and limited. So to address this, the NoSQL database, they actually ignore some of these characteristics. For example, the base is basically the eventually consistent system, which means it's not the real-time consistency, but eventually consistent, sometimes late. Okay, it's a relaxed consistency to focus on performance. Okay, so keep in mind ACID is the most important part of the transaction. So then we need to schedule the transaction. It's not transaction by transaction level, the scheduling. Instead, we are going to focus on writing a data. So operation by operation scheduling. Idea of such a transaction scheduling is to we try to make the serial in one line order for the operation. Okay, based on what? Starting and end time, the transaction timestamp. Okay, so it's called the serializable, but we are not going to cover details of this one. But the idea of this, we try to make the serialized the order of the operation. This operation level scheduling. So I'm going to the scheduling part. it's equal to standard, actually standardized such a transaction management. So they define the transaction as a begin and end transaction, but for the begin, people complain. So do I need to? So definitely, when I try to use the database, that means it's a begin transaction. So it's implicitly, so automatically the begin transaction. Then access mode is read only or read and write. Okay, that is defined by the standard, and also the isolation, different isolation limit. So in the SQL2 standard, read uncommitted, which means even though uncommitted data, you are able to read the data. It's not consistent, which means the very low isolation level. Okay? But on the other hand, serializable means we can schedule everything, no conflict situation. Okay? Even multiple, the transaction can access and modify the data, but it's a serializable. So serializable is the highest level of the isolation. Okay. So phantom is the host data. So the old data or deleted data, but it can be accessed depending on what? Isolation. Okay. So that may happen. So nowadays the serializable, the transaction isolation level is used because it doesn't allow any dirty read or phantom host data and any violation. Okay. Okay, so that is the end of transaction. So this will be basic kind of fundamental of not only just the transaction management itself, but to understand backup and recovery. So I'm not going to spend a lot of time the backup and recovery because it's just a combination of redo and undo. You probably understand if something happened at this time, so we can apply any commit data, apply, do it again. Any uncommit data, we can go back. So that's the idea of the recovery. So, but the more important thing in the backup and recovery is you should have backup. Okay, no theory. It's just a labor work. So you should backup. Without backup, there's no way to restore the data. Okay, when you restore, when you have something problem, you need to restore the data using backup data. How? There's no theory, just a practice. So you should have that kind of scenario. So like for example, each building has a building management the instruction like that. So something the power out, you need to go out the fire, and something we have the something plan. So similarly, database system has such a scenario plan to restore the data in case of something problem type A, type B, type C, like that. Nowadays, if you are using cloud service, the vendor company, they are in charge of such a backup and recovery. So you don't have to worry about it too much. There's a reason more and more small, medium-sized companies try to use cloud computing. So housekeeping job, they will take care. Okay, you can only focus on the developing and so on. But if you are managing the big company, they still have their own IT infrastructure or private cloud system, which means you should be able to understand such a transaction management and then eventually backup and recovery. Then, more importantly, so we are going to use this concept for the consistency management. How to manage keep the consistency later, after Thanksgiving. Okay? So we have the one more class after Thanksgiving. At the time, I'm going to introduce such the consistency management. And then on Wednesday, as I said, where's the Wednesday, the December 1st, we will have the presentation and demonstration for the final project. So during the Thanksgiving, why don't you be ready for that? Any questions? One more time, our final exam is scheduled on December 11th, Wednesday, 10:45 to the 12:45. It's a 2 hour, but I don't think we need 2 hours. It's much easier than the midterm exam. But here, I'm going to use 2 hours. I'm going to give a little bit more information on Monday after Thanksgiving. Okay? Thank you and happy Thanksgiving.